Hi everyone, I am Deepa from Jain University, currently studying computer science and engineering in 8th semester. First of all, I would like to thank Immersive for providing us an opportunity to have an online IoT internship. So the internship started with first of all the introduction to C and C++, then introduction to IoT, then after we moved to introduction to embedded systems, and then we were assigned a project called home automation system using blynk. It was a group project, so we had three members, me, Sachin and Priyanka. We did project together. So throughout this 1 month of the internship program, we have gained various knowledge regarding different topics. Like first, we started with C and C++ basics, then introduction to IoT, then we learned about what are embedded system, how does they work. Then we learned about how to use Arduino IDE, picsimlab and blynk IoT app. Over all the 3 months, we have been exposed to different areas of IoT, including how it works, the technology behind it, and how it can be implemented in different fields. With this knowledge, we were able to develop our skills and implement our knowledge in building a IoT-based project called Home Automation System using the tools and technologies that we have used so far in 1 month. Furthermore, the internship has helped us to understand the importance of IoT in the current technological landscape, where it has been widely used in various industries, like we can see in the today's rising technology. It helps to increase the efficiency, optimize the processes, and enhance productivity, due to which it is getting more popularity nowadays. In this presentation, I will showcase the projects that we have worked on throughout the program, highlighting the skills and knowledge we acquired during this 1 month period. So, in the very first beginning, we learned about C and C++. They are the basic programming languages that are used for developing software applications. The content that was covered was what are the basic data types, what are its syntax, how does operator works, what are its uses, arrays and strings, about different storage classes, pointers, and also user-defined data types. These were the fundamental concepts that are used to write the code in C and C++. We also went through conditions and loop functions, modifiers, preprocessor, classes and objects, constructor, deconstructor, and all. Uh, but here a question arises: what is the use of C and C++ in IoT? So these are the points that highlights the uses of C and C++ in IoT. So it can be used in sensor integrations, control of appliances, in communication interfaces that enables them to exchange data and commands. This component is very crucial in home automation system where different devices need to communicate and work together seamlessly. It is also used for real-time processing by enabling them to respond quickly to the events and inputs. It can be also used for energy optimization by controlling the operation of various devices based on predefined rules and schedules. So basically, we can say that C and C++ are widely used in IoT applications due to their low-level control, real-time processing capabilities, efficient memory management, and hardware interaction capabilities. Now moving to introduction to IoT. So IoT is the network of the physical devices, vehicles, home appliances, or other items that are connected over the internet and exchange the data. It has revolutionized the way we interact with the technology by enabling the devices to communicate with each other. It has many applications across to various industries like healthcare, transportation, manufacturing, and agriculture, where it can improve efficiency, safety, and sustainability. It has also raised concerns around security, data privacy, ethical considerations. As IoT continues to evolve and mature, it presents immense opportunities and challenges for business, governments, and individuals. Use of IoT in home automation system. IoT is used by using the Blink IoT app to control a garden light with an LDR sensor, heater and cooler switch and water tank. It also enables the remote monitoring and the control of these various devices from anywhere, providing convenience and flexibility. Integration of an RDR sensor to automatically turn the garden light at night and turn it off during the day. Automatic control of heater and cooler switch based on temperature sensors to maintain a comfortable temperature in home and save energy. It is also used to monitor and control the water tank level to ensure sufficient water supply and sending alerts when the level is low or when the water is being wasted. It is used for the customization of the user interfaces on the Blink app to provide a personalized experience and simplify device control. Overall, IoT-enabled home automation system using the Blink IoT app can improve convenience, energy efficiency, safety and security in the home. Moving to embedded systems, they are the computer designed systems to perform specific tasks, and they can be integrated with larger systems or products. These systems are usually designed with minimal resources such as memory, processing power, energy consumption. Nowadays, they are used in a wide range of applications like we can see in automotive, aerospace, medical, electronic industries where they perform critical functions as they are designed for a specific task. It can be programmed using various languages like C and C++, assembly languages. As technology grows, embedded systems are becoming more complex and featuring more powerful processor, connectivity options, advanced sensors and actuators, which enables them to interact with the physical world in new and innovative ways. Embedded systems are also used in like same the IoT is used like in sensor integration, control of appliances, communication interfaces, real-time processing and energy optimization. For our project, the requirement was to simulate a home automation system on the picsimlab simulator and use the Blink IoT mobile application to control the devices. Using it, we will be able to control the lights, temperature of the home, inflow and outflow of water in the water tank. So, in this project, we will be doing for garden light control for the temperature system and water tank control. In the garden light control, it will control the lights based on the sunlight intensity. Brighter the lights in less sunlight. For the temperature system, we will be remotely switching on and off the heater and cooler and turn off the heater automatically if indoor temperature exceeds 35 degrees Celsius. For water tank control, it will remotely switch on or off inlet and outlet valves, turn off inlet valve automatically if the tank fills up and turn on the inlet valve automatically if the tank volume drops below 2000 liters. The components used for our project and the hardware component, we will be using Arduino Uno, ETH, PCF, temperature sensor, LCD, LDR sensor and LED. In the software side, we will be using Arduino IDE to write our code, picsimlab to simulate, null model emulator and Blink IoT app to control the water tank and all. So for controlling the garden light, we will be using light dependent resistor LDR. It is used to sense the sunlight and send the analog signals to the microcontroller. It is also used for analog to digital conversion. Like it will be used to read the analog inputs. Only analog pins A0 to A5 connected to ADC block. ADC has three types: sampling, quantization, and encoding. Sampling will break the continuous signals into discrete signals. Quantization will discretize y-axis. Encoding will assign digital value to each signal level. Resolution of ADC, number of encoded signal levels are available, depends on the width of ADC register. In case of Arduino Uno, 10-bit register corresponds to 1024. For the temperature system, LM335 sensor is used that will be providing analog voltage output which is directly proportional to the temperature of the room. In the temperature conversion, analog voltage input is divided by 0 0.01 to obtain the temperature of the room, which is then displayed on CLCD. Arduino UNO is connected to the internet using ETSW5500 Ethernet shield. Heater and cooler can be remotely controlled using the blynk mobile IoT app. Data streams are acting as virtual pins, and they are created by blynk dashboard templates for exchange of data between mobile app and the microcontroller. In case of water tank control, a serial remote tank simulator is used here. To control inlet valve or outlet valve, it will send a byte followed by another byte using serial.write. 0 into 30 byte is sent to request the data from volume sensor. Serial.read is used to read the volume in 8 bits. Null emulator, it is used to set up serial communication between picsimlab and serial tank. This is the whole architecture diagram for the project. Here we can see that CLCD temperature system and Ethernet shield is connected with Arduino through the pins. LDR is connected using A0 and A1. We have used Arduino IDE to write the code. I will show that. So here are all the codes for that are required to simulate our project. This room here. To connecting Arduino to the blynk cloud, the code is there to initialize temperature system, initialize the serial tank, to keep the timer running, to control the brightness of the LED, to read the volume water. This is LDR, this is LDR.header, this is main.header, this will be serial tank.header, this is temperature system, and this will be temperature.header. After that, we will open our blynk console. I have already opened it. So in the data streams, we can see cooler pin, temperature sensor, heater pin, volume, inlet valve, outlet valve, notifications. After opening the blynk console, we will be opening picsimlab. Here, when we go to the tools, we will be seeing serial remote tank. So we will be using our COM2 and we will click on connect. I have already connected it. So that it's already connected. After that, we will go in modules and we will click on spare parts. When we click on spare parts, it's taking a little bit of time. But let's forget it, as I have already opened it. Like spare parts will be seen like this. After that, we need to upload our code. We can click on file, load hex, and this is the code. This is the bootloader.hex file. We can click and open it. After that, we can see that in our phone, I have connected my phone using this A power. So here we can see that it's online. So when I will click on home automation, it will show like temperature system and water system. When I move to temperature system and this is spare parts, so in cooler, when I will click on the cooler will open. After switching it off, it will off. When I click on heater on from my phone, it will on. And when the inner temperature which is 35, it will switch off automatically. We can see it switched off automatically. While moving to water system, When I will click on inlet valve on, we can see that inlet valve is on and it's off since it has already reached 3000. We have kept in our code that when the water volume reaches 3000, inlet valve will be switched off automatically. I will click on outlet valve on. When I clicked on outlet valve on, when it will reach to 2000, it will inlet valve will be on automatically. So we saw that when it reached 2000, inlet valve was on automatically, and we'll keep the outlet valve off. Then the water level will increase, and when it will reach to 3000, it will be automatically off. We saw that. Moving for the garden light. When we will decrease this, then it will be dim, and when we will increase it, garden light will be on. I showed all the simulation part. So this was for the cooler, and this is in the mobile app. So while concluding it, the whole 1 month IoT internship has been a valuable learning experience for all of us. We have gained a solid foundation in C, C++ basics, IoT and embedded systems, and learned how to work with popular IoT development tools such as Arduino IDE, picsimlab and blynk IoT. Many of the technology was new to us, but it was very smooth learning experience. We learned everything step by step. Through hands-on projects, we were able to apply our knowledge and skills to build practical IoT-based solutions. We have also gained a deeper understanding of the potential of the IoT technology and its impact on various industries. Because of this internship, now I'm eager and even thinking to move on to the next steps to have more hands-on experience in IoT. It has developed our interest towards IoT. We hope that skills and knowledge we acquired through this internship will be beneficial to us as we continue to explore and contribute to the field of IoT. I am very grateful to all the mentors and organization of this program for providing us with this opportunity. Thank you for all the attention and all the things that you have provided, and we hope that you enjoyed the presentation. Thanks. Thank you.